Welcome back, you fans of Fuzz. Done a little bit more experimenting with the power situation on the Fuzz Aldrin. Yesterday I did a lot of tests involving underpowering it, reverse powering, no power at all, and all of those situations worked. Well, the guy watched the video and he sent me a picture of the wall wart that he was using, and it was by Electro Harmonix, and it pumped out 9.6 volts DC, but only at 200 milliamps. Now the ones that I use are 1,000 milliamps or 1 amp. So I'm really thinking that maybe it's not a voltage underpower situation. Maybe it's a current supply issue. So I've set up this test apparatus here, having some fun with the soldering iron and with my newly repaired voltmeter, which has been in another video. Not trying to pimp my own videos, but hey, watch some more videos of mine. That's cool. All right, so what am I doing? This thing, I figured, how much juice are we putting in here? 9.48 volts. All right, so if I am feeding this thing, where can I put my numbers here? 9.48 volts. Oops, now my pin broke. Time to get the JB Weld again. Alas. Or I can just use it like this. 9.48 volts DC. Check one more time. Yes, indeed. 9.48 volts, even though there's a little bit of a reflection on there. Let's try this again. 9.48. Ta-da! All right. Now then, what is this thing doing? This thing is taking the voltage and it's running through this 10K potentiometer here, and it's putting this resistance in series with the power supply to this. Now, why am I doing that? Because I'm in essence making a potentiometer out of, I've got the power supply coming in, and that's going through, wow, I need to fix my pin first. I'll be right back. There, I fixed the pin again. I should point out that this is sort of like the magic 8-ball of ballpoint pins. Okay, will it work this time? No brainer. All right, so this is obviously the setting the pin needs to be on. All right, what I was trying to do before. Positive comes in from the same power supply I was using yesterday, and that's going to go through the potentiometer, but it is set up as basically just a variable resistor, and that's a 10K value. This is where the power goes into the Fuzz Aldrin. I'm trying to make this thing right. And then that's going to go to the return, which is ground. So do my symbol for ground. All right, positive, some variable resistance, the resistance of Fuzz Aldrin, and to ground. That's the same exact thing as having a potentiometer, aka volume knob. Confound you! Time to get the super glue out, I can tell. So this circuit right here, power supply going to the Fuzz Aldrin through this device, is the same thing as a garden variety volume knob. So if I was putting in the 9.48 volts up here, I could dial it back, and somewhere in the middle, when I would have 5K and 5K, I would expect the value coming out here, out of this end, to be half, right? Because that's what a volume knob or voltage divider does. It gives you half. Well, in this setting it does. All right, so if I set this and the voltage going into Fuzz Aldrin is half right here, which I can measure, I'll, in a sense, know what the resistance there is. All right, so let's try that out. 948 volts. If I divide that in half, I've done my math in advance here, so this should be, half of that is 4.75. Right? Is that right? Nope, something's not adding up. 4.74. Right. 4 and 4 is 8. 7 and 7 is 14. Carry the 1. 4 and 4 is 8. Plus the 1, 9. All right? No Common Core math here. Doing it the old way. And doing it in my head. Even though I have some cheater stuff over here that you can just barely see. Alrighty. Now, the magic of television. Stand still. This is always the hardest part of any video, is getting the stuff set up so it can be read. Now then, if I read from here to there, that's my 9.48, and there's a little connection in here where it should be, that's 4.71. If I nudge this just a little bit with my finger, 4.7, it's going the wrong way. Come on. Trust me, this will be worth it. .74. All right. So at this point, this potentiometer, this guy, has the same resistance of all the electricity going through the fuzz. All right, because I'm measuring it at that halfway point. So let's disconnect this power. Disconnect that guy. Disconnect the fuzz. So now I should be able to get a reading of just the resistance value of this resistor, or varistor as the case may be. All right, so 963 kiloohms. So that's 963 ohms. I really, really hate this pin. All right, you asked for it. Today's episode is brought to you by Loctite Super Glue. It's actually not. They're not a sponsor at all. If they wanted to, that would be cool. So, pretty much everything that I use is held together by super glue or scotch tape or duct tape or JB Weld, which was our sponsor the other day. All right. Hooray. It's all fixed. What do you think about that? No brainer. Okay, let's do the math. So 963 ohms, and that's going to be 4.74 volts across that. Should be 4.74 volts across that as well. So whatever this resistance is, that should be the resistance of this circuit. So remember Ohm's law, V equals I R, and voltage is 4.74 current. We can divide by the resistance, which is 963. And I cheated and used a calculator. And what does that give me? Everyone sing along. 4.92 milliamps. So a 200 milliamp power supply should be able to supply that with no problem at all. And now I am back at square one. All right. So what I'm going to do now, I've ordered the exact same power supply that he's using, and when it comes in, I'm going to see if it does the same behavior. It didn't do any of the stuff that I demonstrated yesterday. For him, he plugged it in, and the light came on when he activated the effect, but there was nothing coming out except for an occasional pop or a click noise. The only thing I can think of is that there's something particular about that power supply from Electro Harmonix. Lord knows. Yeah. So the mystery deepens, and I'll see you guys in, I guess, part 3. Be safe.